Hello everyone and welcome to this video. I am Saurabh Singh Kushwaha. I'm from IIPSD ABB College. I'm from MTech IT 5th semester and this project is guided by Mr. Shaligram Prajapati sir. And let's start the video. So here in this video we are going to discuss the test paper 4 of our internal paper. So let's start the video. So the first question is, suppose you are given the following data items to cluster, and this is the data items like 2, 4, 10, 12, 3, 20, 30, 11, 25, and the value of k is 2. The k value represent the number of clusters that we have to form. So here we have to form two clusters. Now using Euclidean's distance computation, applying the k-mean clustering and finding out the final clusters. So this is the question. We have to form two clusters using the k-mean clustering method, and the algorithm is also given like input if t1 t2 is the data set, k is the user input, whether we have to find out how much clusters, desired clusters, then output will also be k, the number of clusters, and this is the algorithm that we have to follow for solving the question. So let's see the solutions to. Now here, the following are the solution for this question. First is initialization. So first we have to set, we have given that k is equals to 2 in the question. So first we have to randomly select two initial clusters centers. So हमें कोई भी data set इस randomly select कर लेना है in data set में से. So for example, let's say we have to choose 2 and 20 as the initial centroids. We have chosen them. Then assignment. Now for each data point, calculate the Euclidean distance to each centroid and assign the data point to the cluster with closest centroid. Then after finding out these two clusters, we have to update the centroid. So for updating the centroid, we have to calculate the mean of the following data points in the clusters and repeat it until we have two centroids that are not changed in two iterations, and that will be our final cluster. So let's see with example and solution. Now given here is 2, 3, 4, 10, 11, 12, 20, 55 and 30. Now consider that there are two clusters k equal to 2. Now we have to take, let's mean 1 is equals to 4 and 2 is 12. Now we have taken 4 and 12. Now the first cluster will be 2, 3, 4 because these are closest to 4, and second will be 10, 11, 12, 20, 25, 30 that is closest to 12. Now updating the cluster centroid, so 2, 3, 4 plus divided by 3, this will give 3. So now the new mean one will be 3, and similarly for mean 2 we have the updated value as 18. Now with 3 and 18 as our mean values, we will form another cluster with respect to them. 2, 3, 4 and 10 will be in the first cluster and the remaining will be on second cluster. Now again updating the centroid, so 2, 3, 4, 10 will be added and then divided by 4. This will give 4.75 and same as for M2 and that will be given 19.6. Now again we have to find out the cluster using these new values. So the new clusters formed are this, same applying the mean and updating the centroid. So here the clusters were formed were like 2, 3, 4, 12 and 10 and 11, and K2 was 20, 25, 30. Now after updating, cluster formed is same, and the mean and the both mean are also getting the same. So these are the new cluster and these are the final cluster that we were looking for. So in this so from this method we can find out the clusters for a given data set. So here we have finished our first question. Now let's move into the second question. Now the second question has given an data set with transaction values, and here we have to find out the valid association rule. That means For example, here it is given like bread, jelly, peanut butter. So we have to find out a rule whether if a particular bread is taken, then what is the chances that peanut butter, jelly, or milk and any product will be also taken or associated with it, and what is the probability for that, so that we can make a rule to that. So here is the question, transaction, and the algorithm associated with it. Here we have to find the support and confidence as well, and the minimum confidence is given as 70%, and minimum support is given as true. Now with the help of this minimum confidence and support, we will find out the new association rules for this given question. So let's solve the question by solutions. So let's move into the solutions. So here is the second one. Now here given transactions like T1, T2, T3, T4 and T5. Like in first transaction, bread, jelly, peanut butter were taken. In second transaction, bread, peanut butter were taken. In third, peanut, bread and butter were taken. And say beer, bread and beer milk were taken in T4 and T5 respectively. And the minimum support is given 30%, confidence is given 50%. Now, minimum support is given as 30%, so 30 into n is the number of transaction, 30%, so this will give 1.5. So firstly find one item set and its frequency occurrence. Now we have to find one item set frequency. So here we have to write the bread, jelly, peanut butter individually and the frequency of their occurrence in every transaction. So like here bread has came 4 times, jelly 1, 3, 2, 2. Now here the jelly frequency is lower than the minimum support count. That is here you can see that jelly is 1, but in the in this value we have calculated that minimum support count should be 1.5 or greater than 1.5. So this does not meet, so we will discard jelly from this table. Now we will find out the two item set. So two item set will be combination of these remaining items, like jelly was removed here. So first bread and peanut butter frequency was 3, then bread milk was 1, this was 1, peanut butter milk was 1, 0, 1. Now again removing two data set whose frequency is lower than minimum support count. So as we know that the minimum support count was earlier we have calculated was 1.5, but here we can clearly see that only bread and peanut butter have maximum frequency than the minimum support. Everyone has lower than the minimum support, so we will discard every other items and we will only take bread and peanut butter. Now as there is no any other there is no option for three associations, so we will now calculate the association rules, form the association rules. First rule we can find that when we take bread, then what is the chance for peanut butter? So it will be 3 by 4, because 3 is the number of frequency for peanut butter, 3, and for bread it is 4, will be 75%. The confidence is 50%, so this is greater than the confidence percent, so this rule is valid. Now from peanut butter to bread. Now bread, the peanut butter and bread. Here the bread and peanut butter frequency is 3, and for peanut butter frequency was 3. So 3 by 3 is equals to 100%. So this is also a strong rule. So in this way we have formed two rules of association, that whether if bread is taken, then it is likely 75% chances that peanut butter will also be taken, and if peanut butter is taken, then it is 100% chance that bread will be also taken. So in this method we have find out the association rule for this following item set. uh, this is it.